Thank you for downloading this podcast from Talk Radio 702 and 567 Cape Talk. For more podcasts and more information on your number one news and talk station, please visit 702.co.za or capetalk.co.za.
Stand up for the law. Stand up for decency. Stand up for compassion. Stand up for respect. Stand up for your community. Stand up for your future. Stand up for South Africa. LeadSA.co.za.
The Naked Scientist on Talk Radio 702 and 567 Cape Talk with Reedy Clubby.
It is 28 minutes to 10 o'clock. You know what we do for the next couple of minutes. Anything that you want to ask Chris, join us as we take your science-related questions. We're stripping science down to its bare essentials. If you are curious about how things work, how they are made, do give us a call on 021-446-0567, 011-883-0702. Chris, good morning.
Hello, Reedy.
Are you well today?
Yes, I'm very well, thank you.
Lovely to hear your voice. Okay, let's get on with it then. We've got some SMS questions from last week. Somebody wants to know, can varicose veins turn red by doing deep breathing?
Can varicose veins turn red by doing deep breathing? Well, the reason that veins aren't red is because of a trick of light. In fact, if you were to open up the skin and look at the vein itself, varicose veins in any vein, although they look blue, they're not really blue. And if you take blood out of the vein, it's still red. And the reason that veins are blue and, look blue and are actually red is because of a phenomenon called color constancy. And what happens is that when you shine light on the skin, when you look at the skin, red light goes into the skin quite well, but blue light gets absorbed or scattered or reflected by the surface of the skin relatively easily. So by the time you get deeper into the tissue to the level where the veins are, you've got blood light, which is mainly just red light, reaching that bit of tissue. And because the vein contains slightly darker red blood than the surrounding tissue, it absorbs a little bit more light than the surrounding tissue does. So the light that then gets bounced back from the area where the vein is red minus a little bit of light. And because of the way the brain decodes colours, it makes the vein look artificially darker than it really is. So it creates a sort of purple colour. And there was a scientist in Germany who about 10 years ago did some very elegant experiments to prove that this is just a trick of the light and veins aren't really blue. He took a solution of milk and he took a pretend blood vessel which had some real blood in it, and he had the tube on a sort of a system so he could raise and lower it in the milk solution, and at the surface of the milk the blood you could clearly see in the tube was red, and as it went deeper and deeper into the milk solution it looked darker and darker until it went blue. And milk was a good equivalent to skin, because milk contains lots of tiny particles that scatter blue light really effectively, but red light goes through more easily. So it was a way of making modelling the scattering effect that you see. So I'm not convinced that doing anything to your breathing is going to make a difference to the colour of the varicose veins, because the tissue over them isn't going to change.
Okay, let's go straight to the lines then. And David, you are calling us from Sandton. Good morning.
Good morning, Reedy. Good morning. How are you guys doing today?
Fine, thank you. Your question, please.
Excellent. I just wanted to know something. In terms of petrol, I always wondered, the 93 octane and 95, is it really true that 95 will give you more kilometers than 93? What is the whole concept behind that whole 93 and 95? I just always wondered. I don't know if it's for real or what's the story.
Are you referring to when you see these premium fuels, though, that you can buy them and they cost about 50% more, and you're thinking, I'm getting a tank full of fuel and it's costing me twice as much. Is this really going to translate into better performance? Is that sort of what you're getting at?
Well, Chris, you know what? They always say, put 95 in, cost a little bit more, but you will get a little bit more kilometers onto it. So, I don't know, I always do it anyway, but I don't really know if it's true. I mean, one of these things, I just can't ask, it's one of those things.
I've got a friend who does the same as you, and he's got a Mercedes, one of those little smart cars, and he finds that he gets a lot more distance out of the tank if he puts the premium fuel in. If you ask people who are in the industry, they will tell you that not all petrol is equivalent. And when you buy cheap fuel from a cheap source, although it looks like you're pouring the same stuff in your car and it runs, the thing that hasn't been done to that fuel is a combination or a cocktail of clever things called the additive pack, and not in there. And when petrol stations or refineries actually make high-quality fuels, what they're doing is they're tweaking the chemical formula and they're adding additional materials into the fuel, which makes its properties change very subtly. And those properties can include it burns slightly better, it burns slightly more completely, it also has detergent molecules in it which clean the engine as it goes through, which means that it's less likely to make deposits on the inside of the engine. It can also clean off some of the deposits on the inside of the engine. So obviously adding those extra chemicals costs money, which is why they price it up. But they say that there is a benefit to the longevity of your engine and how many miles to the gallon you're going to get. So I think I believe them, otherwise they would be done under the Trade Descriptions Act for flogging you something which does no good. But I don't actually know what the chemistry is. I suspect it's a closely guarded secret, but there's definitely evidence that these more expensive fuels will benefit your engine.
Okay, thank you very much, David. Tanya in Krugersdorp, hi.
Hi, good morning, Reedy. Good morning, Chris. I want to know, do all male mammals have nipples, and why?
Hello, Tanya. The answer is that nipples are an embryological phenomenon. In other words, when you're developing in the uterus, either as a mammal or when you're even if you're developing as a different sort of animal, like a marsupial, the thing is that the body develops as a sort of initially a flat plate of cells that then curls itself up into a tube, and along the axis of that tube is a special structure called a notochord, and this has a series of different segments to it. And those different segments express different patterns of genes, which then tell the overlying tissue at various points along the body surface what to turn into. And that means that the body is patterned into a series of segments, rather like a centipede. And one of those segments has got the instruction to make nipples. That message occurs irrespective of whether or not you're male or female, because it's a developmental phenomenon, it's not a sexual phenomenon. And it actually occurs earlier in development than the body actually deciding whether it's going to be male or female in terms of its outward appearance anyway. Those nipples also contain glandular tissue and can be functional. So if a man stimulates his nipples and also is exposed to the chemical prolactin, which a woman makes when she is going to lactate, then a man's nipples can also become active and produce milk. And in some species, there is actually lactation as a natural phenomenon. There's a species called the Dyak bat, which does actually take part in breastfeeding, and I think about 20% of the young bat's milk intake comes from the father. So the nipples are, I think, a ubiquitous phenomenon, and in some cases they're functional.
Thank you very much, Tanya. Thank you. Let's go to Lundu. Lundu, you are calling us from Davidson. Hi.
Good morning. I'd just like to ask my friend why is there no male contraceptive pills or male contraceptive injections? Just like, so why is it so difficult to develop that if, like the science behind it?
Because the world has something against us women. That's what I think. Chris?
Yes, I guess that the person who actually came up with the recipe that enabled the female contraceptive pill was Carl Gerasi, who was working in California. He did it a long time ago now. I think it's 40 or 50 years since he came up with a chemistry that enabled us to make artificial hormones that would suppress ovulation. The answer is that I think partly it's the social and sexual phenomenon, and partly also it's a biochemical problem. The social one is that pregnancy costs women much more dearly than it costs men. For men, it's a certain length of time of fun. And for the women, they have to live with the consequences, not just for the 9 months that they're pregnant, but then for the 19 years they finally get rid of the child off to university or school or get married themselves. So women have a much higher price to pay if they accidentally fall pregnant, because obviously in some countries the mortality rate from pregnancy is as high as 25 or 30%. I mean, we've got a lady working in our pathology department at the moment from Uganda, and she is routinely reporting mortalities of 30%. One person in 3 dies in childbirth, which is tremendously high compared with other countries. So for that reason, I think that women, because they had such a lot to lose in the equation, actually were more likely to be grateful for the oral contraceptive pill. And so straight away there was a view that the problem had been solved. You take this pill and women don't get pregnant. I think that probably slowed things down a bit and meant that people didn't worry so much about the blokes. I think there's also less of an incentive for men to take a pill. And then there's the question, if you were a woman and you were about to go to bed with a man and he said he was taking this thing, would you trust him? Or would you trust him to have taken it or to have remembered to take it? And so I think that there's so much emphasis on there's a solution for women that means they're in control, that largely it's meant that men have escaped to a certain extent. Also, the chemistry they've tried to do to produce a good quality, effective male contraceptive pill hasn't been very successful at stopping sperm production, because when you take if you try and stop the sperm production, it'll stop it for a while, but then it doesn't stop it immediately. So when is your safe window when you're no longer fertile, and how quickly does fertility resume afterwards? And these are all uncertainties which obviously make women and men nervous about trusting a male contraceptive pill. So the solution hasn't been reached yet. People are trying to make pills now, rather than manipulate the hormones in the same way that it works in women. They're trying to make pills that will actually stop the sperm. Even though the man continues to make sperm, they will stop the sperm from being active all the time that the person is taking the drug, and then when you stop the drug, then the sperms can resume their activity. I don't think they're there quite yet, though.
Well, to answer your question, would you trust a man to take contraceptives? An emphatic no, Naked Scientist. Absolutely not. Okay, let's take a break. We'll be back with more of your calls. Matthew and Kenneth, we'll chat to you just now.
The Naked Scientist on Talk Radio 702 and 567 Cape Talk with Reedy Clubby.
Straight to Matthew in Cape Town. Good morning. Welcome to the show. What's your question to the Naked Scientist?
Hi, guys. I once heard a quote, or someone once quoted a fact to me, and I wanted to check that it was actually true. I heard that the heart of a mammal would beat the same amount of times, regardless of the mammal, in an average lifetime. So that's why a human and a dog, they say a dog will live, 7 years to 1 human year, and that's because of the actual heart, and that the heart would beat the same amount of times on average in a lifespan. I wanted to know if there was any truth to that.
Okay.
Hello, Matthew. I don't have the absolute numbers to mind. I can check it. It doesn't sound too unreasonable if you think that a sort of human heart is beating at about 70 beats per minute. But if you go to a little bird, or you take a rat or a mouse, then their hearts are routinely beating at many hundreds of beats per minute. And obviously a mouse burns out after a few years, at most, probably 2 years. A rat can go on for a little bit longer, a human can go on for 70 years, and some birds, like parrots, maybe can live 100 years. Because we did actually answer this on the radio a few years ago, as do I get more than my fair share of heartbeats? I think there is a relationship between size of animal and number of heartbeats, but it really all comes down to the bigger you are, the more controlled your metabolic rate is. Small animals have a very high metabolic rate. They produce lots and lots of reactive oxygen species, free radicals, which damage tissue, and so they effectively burn out their bodies more quickly. And to sustain that high metabolic rate, they have a high heart rate. So it's not that the heart is effectively having X number of beats and then runs out. It's more the heart rate is a reflection on the metabolic rate, which the animal's having to operate, and the metabolic rate effectively determines how quickly it burns its body out.
I've got a tweet here, Chris, about the male contraceptive. Somebody sent a tweet to say there's a team at the University of the Western Cape's Medical Biosciences Department currently working on male contraceptives. It would be great to get them on the radio and hear more about their work. Yeah.
Indeed.
Yep. And then, here's an interesting question. Please ask the Naked Scientist, which organ or part of your body stops functioning when you die, or does it depend on what you die from or of?
Yes. Well, I think that they really give the clue in the last part of their answer, which is that it depends what kills you. If you have a heart attack, what has happened is that the heart, which has a regular beating rhythm, that's what you feel when you feel your pulse or place your hand on the left side of your chest, assuming you haven't got dextrocardia, and you feel this thing beating, your heart is going through a regular cycle of activity, which is pushing blood around your body. If, for some reason, whether it's a heart attack or some underlying electrical problem or a biochemical problem, the heart muscle stops beating, then all of the other organs cease to see a flow of blood. The most sensitive is the brain, and if the blood flow to the brain is interrupted for a fraction of a second, actually, then the brain very quickly stops working properly and you lose consciousness. So when someone dies of a heart attack, effectively their heart has stopped beating. they deprive their brain of blood and they lose consciousness. Other organs may be a bit more robust and resilient against the lack of blood flow for a little while. So that means there is an opportunity to try to resuscitate somebody and get their heart going again. But when someone dies of, say, a stroke, their brain has had its blood flow interrupted for another reason. Either they've bled into their brain or they've bled around their brain, but either way, the brain again is deprived of blood flow. When someone dies of a disease or a sickness or malaria or something like that, what's actually happening is that the body, every organ is being affected, and you've got a biochemical disturbance, a metabolic disturbance, and all of the different organs get impacted and stop doing their jobs properly. So all of the body's chemistry goes off kilter, and you end up with what's called multi-organ failure. And that can eventually then compromise the ability of things like the heart to supply the brain. And so death isn't so simple as just saying there's one thing that goes wrong and this causes everything else to fail. It can be any number of organs, all of which are absolutely essential. And if they don't do their job properly, then their knock-on effect impacts on the ability of other organs to do their job, and eventually everything just stops.
Okay, let's go to Kenneth in Johannesburg. Hi there, Kenneth.
Good morning, how are you?
Fine, thank you.
Yes. I just wanted to find out that why are we not using diesel in aeroplanes, seeing that actually it's more eco-friendly and, well, it's available, cheaper than petrol.
Diesel in aeroplanes, okay.
Yeah.
Chris?
Hello, Kenneth. Well, what we actually use in aeroplanes, it depends on the aeroplane. But if you've got a propeller-driven aeroplane, most of them run on a fairly high-spec unleaded. So small light aircraft with piston engines in them effectively are running in a very similar way on a similar fuel to a petrol engine in your car. But if you go on a jet, then jets are using aviation fuel, which is a bit like, it's effectively kerosene or paraffin, which is about as heavy, a little bit lighter than diesel. So effectively they almost are running on diesel. And the way a jet engine works is that you have that huge fan on the front, which is pulling in air. The air is getting compressed by a series of compressors at the front end of the engine, which as you compress the air, make it get hotter and hotter and hotter, a bit like a diesel engine. And you then squirt the fuel into the combustor, which is in the core of the engine. And when the fuel gets into the combustor, it sees this big cloud of extremely hot gas, and the fuel then burns fiercely, and the temperature flies up to about 1500 degrees C, and the pressurized gas, which is now taking up a lot more space than it did before because the fuel took up very little space and it burns to make lots of gaseous products which take up lots of space. This then forces its way out of the back of the engine through a series of turbines, and as it goes out, it makes those turbines spin. They're connected to the compressor on the front of the engine, so you have the air being pulled into the front of the engine and forced out of the back, plus you have the hot gases coming out of the back, and that whole thing generates the thrust. And that's how a jet engine works. Rolls-Royce have this quite nice way of putting it. They say suck, squeeze, bang, blow. That's how a jet engine works. Rolls account for about a third of the engines that are keeping people aloft in the air. And but basically they are burning something very similar to diesel.
Okay. And an SMS says, when you rub and shine silver and gold jewelry, why is there so much black on the cloth?
The reason that silver tarnishes is because silver is actually relatively reactive with sulfur. And there's trace amounts of sulfur in the atmosphere, usually in the form of sulfur dioxide, often from things like diesel fuel and petrol, because hydrocarbons contain small amounts of sulfur. Much less so these days than historically. Refineries now remove a lot more of the sulfur than they did, but this means that you get sulfur dioxides coming out of the exhaust pipe. If they see a bit of sulfur, they react. If they see a bit of silver, they react with the silver surface and they make silver sulfide, which is a black color. And when you clean the silver, effectively what you're doing is you're using a mild abrasive, which will rub off the silver sulfide and reveal the nice pristine silver beneath again. The problem is if your object is made of silver plate rather than pure silver, eventually you'll rub off all of the silver surface and you'll get down to the base metal underneath, which is a much less attractive color.
Okay, and is it Ritesh in Glen Vista? Good morning.
Yes, hello.
Hi.
Yes, I'd just like to find out from you, what's the purpose for why they call lightning a phenomenon?
What is the question again? Sorry, I didn't catch it.
Why do they call lightning a phenomenon?
Why do they call lightning a phenomenon?
Yes.
Well, I think the word phenomenon means something occurring, and I'm not really sure why lightning would be, why anything wouldn't be a phenomenon really. but if you want me to explain why lightning happens, it's because you have these tiny particles of ice crystals. They're called hydrometeors. They're little ice crystals in clouds, and there are big ones and small ones, and they're jostling around inside clouds on air currents. And in the same way that when you rub a balloon on your hair, you can make it become statically charged, so it'll do things like pick up pieces of paper or stick on the wall. These hydrometeors jostling around inside clouds acquire an electric charge, and for reasons we're not 100% sure on, ones which are negatively charged end up at one side of the cloud, and the ones that are positively charged end up at the top of the cloud. And this means that you end up with an electric field between the base of the cloud and the Earth's surface, which eventually produces a sufficiently strong electric field that the air itself becomes ionized, in other words, conductive, and then the electricity takes a path down to Earth through the most ionized bit of the air. And as soon as it's ionized enough air to connect the circuit, if you like, then all of the current flows in a fraction of a second down through that tiny thin strip, which is actually smaller than a 1 rand piece, the lightning bolt that you see. But it has a current of tens of thousands of amps and may discharge maybe 10 billion joules of energy in one go. And this is enough to heat the air around the lightning bolt to about 30,000 degrees C. And that's actually 5 times hotter or 6 times hotter than the surface of the sun. And that heating effect expands the air around the lightning bolt very, very quickly, and the air can't get out of the way sufficiently fast, so you get a shock wave or a sonic boom, and that's the thunder that you hear afterwards.
Okay, and I have an SMS here. Somebody wants to know, can mental illness be ever cured like other illnesses that people have?
I think the answer is almost certainly, but it again depends on what the cause of the mental illness is. If someone has a mental illness because one part of their brain is connected to another part of their brain that it shouldn't do, which we think underlies certain mental problems, or someone has a mental disease because a part of their brain has been destroyed, perhaps by a parasite or by an infection of some kind or by a stroke or something like that, it's much more difficult to see how that could be put right. But many common mental illnesses, like depression, we're now getting quite good at understanding what causes these disorders and how to put them right. And there are very large selections of drugs available now which effectively help the brain to reconnect itself together in the right way, either to reverse or to compensate for the misconnection or the biochemical problem that was causing the mood disturbance, so that the person then functions better. And the idea is that you can use antidepressant drugs and things like that as a sticking plaster. Effectively, you help the brain to heal up the connections that have gone wrong, and then when you take the drugs away, the person is feeling much better and they don't need them anymore.
Chris, as always, a pleasure. Time just flies and the questions are just coming in at a very frightening pace. We love it. We'll chat to you next week.
All right, Reedy. Have a nice weekend, everybody, and see you next time. Bye-bye.
Bye-bye. That's Chris Smith, the Naked Scientist, and it will be available as a podcast, and we will check it before we all go home and make sure that it's loaded properly, so you can download it from our website anytime after 1:15. Thomas, does that suit you? Will you have digested your pie and your fried chicken and your jelly beans and your ultra milk custard and your muffins and everything else that you snack on?
Let's just be around 1:30.
1:30. You need a bit more time to chew the muffins today. Okay, darling.